Good morning, methods class. Welcome to week 2, lesson 1. I hope you're having a good day. So last week we looked at the sine rule, which worked for any triangle, not necessarily a right angled triangle. The sine rule said that given any triangle, the ratio of the side length and the sine of the corresponding angle is the same for all three sides. Where the corresponding angle is the angle which is opposite the side. In particular, we looked at the ambiguous case of the sine rule, and this is because of the CAST diagram, where the sine can be positive value depending on quadrant 1 or quadrant 2, whether it's an acute angle or an obtuse angle. So it's very important to check for ambiguous case when you're doing questions. Today we're going to look at the cosine rule, which is another rule relating triangles. It works for any triangle, not just right angle triangle. So this is page 7, cosine rule. So what is the cosine rule? Well, let's derive it. So consider a triangle ABC over here. So remember, we label angles with capital letters and the corresponding sides with the lowercase letters, and corresponding sides are the opposite sides to the angle. Let us first define this perpendicular line H from B straight down to this new point called D on the line AC. So H, the perpendicular line, so that gives us that here we have a right angled triangle for both AD and DC because H is a perpendicular line. Because we have a right angled triangle, we can use Pythagoras or SOHCAHTOA. In particular, if we focus on the left triangle ABD, we have the hypotenuse C, because that's the side which is opposite angle C. We have the perpendicular height H, and we define the length AD to be X. So if we use Pythagoras, which says the hypotenuse squared, so C squared is the sum of the square of the other two sides, is equal to H squared plus X squared. Now, if we consider the right-hand side, a right-angled triangle BDC, we have the hypotenuse A, we have a side length H, that was the perpendicular height. Now, on the bottom, DC can be written as B minus X because the total length of AC is B, because that's opposite the B angle, and AD was X, so subtraction, we get B minus X. So again, because it's a right angle triangle, CBD, we can apply the Pythagoras theorem. So A squared hypotenuse squared is H squared plus B minus X in brackets all squared. Now let's expand that bracket. So A squared is H squared plus B squared minus 2BX plus X squared. Or rearranging, A squared is H squared plus X squared plus B squared minus 2BX. Now, if you go back up to equation 1 on the left-hand side triangle, we said that C squared is H squared plus X squared. So we can replace the H squared plus X squared in the second Pythagoras equation. So we get A squared is C squared plus B squared minus 2BX, or rearranging, A squared is B squared plus C squared minus 2BX. So in our original triangle, we only had values in terms of A, B, and C, not X. So in this equation of 2BX, we want to find a way to replace the X with a relationship between A, B, and C. How do we do that? Well, let's focus on the left-hand side right angle triangle ABD. So we focus on angle A in particular. Cosine of this angle A is adjacent, which is side length X, and hypotenuse, which is side length C. So cos of A can be written as X over C. Rearranging this, we can say X is C times cosine of A. So we can replace that with the X in the 2BX. So A squared is B squared plus C squared minus 2BC times cosine of A. So you can notice the pattern here that if I want the side length A squared, then it's the cosine of that corresponding angle A. and then you're adding the other two sides squared, but you're taking away twice of the other two sides, lots of cosine of your angle. So most of the time the textbooks would write it in the form of c squared equals a squared plus b squared minus 2ab cos c. I tend to prefer to memorize it in the rearranged version, which says cosine of the angle of interest c is you add the other two sides squared, you take away your side squared, and you divide by 2 lots of the other two sides. So I prefer to memorize the cos c version, or you can see the textbook. The textbook gives you the c squared version in the box there. So again, the way I remember it, the cosine of the angle which I'm interested in, c, is the sum of the other two sides, a squared plus b squared, but I take away my side, c squared, and I'm dividing by twice of the other two sides. So when do we use the cosine rule? We use the cosine rule when you have case when you're given 3 sides and you want an angle, or in case 2 you're given 2 sides and you're given one angle which is squished in between the 2 sides, and you want a side length. And when I say squished, it means like this. If you're given A and B sides, then this angle is what you're given, this squished in between the angle between the 2 sides of a triangle. So that's when you would use the